So I'd like to introduce Dr. Charlie Kemp. He's going to be sharing with us today about what will it take to get human scale mobile manipulators to be happily used in the homes that we live in, and by people of various abilities and with some disabilities. A little bit about Charlie. So, I guess I can't say Professor Kemp anymore, Dr. Kemp. He is currently the co-founder and chief technology officer at a company called Hello Robot. Hello Robot makes a bunch of these stretch mobile manipulators. You may have seen them scattered throughout campus. You'll see a bunch of them in the AI makerspace just down the hall. You'll of course see them in the slides. They have benefited research substantially. Prior to creating the company, he was at Georgia Tech, where he was a tenured professor. He created in 2007 the Healthcare Robotics Lab of Georgia Tech, and he was there doing research, leading a research lab until 2023, where he left Georgia Tech to go full time at the company. And that was, shortly after they released their robot. And you'll see more about that today. While he was at Georgia Tech, doing lots of really cool things. Of course, he has a slew of awards: Google Faculty Award, 3M Faculty Award. He has several teaching awards, NSF Career, multiple Best Paper Awards, over 120 peer-reviewed publications. So a very proactive researcher, and still does research to this day in various amounts. Let's see, what else am I missing?
You've done great.
I think I've hit many of these.
I feel honored, and it really is a treat.
I think the cherry on top is Charlie was also my PhD advisor.
I got
PhD. With that, I'll hand it over to Dr. Kemp.
Thank you, Zachary. That being introduced by your former student is a true pleasure. And to do that without notes and get it right, which you did, I'm impressed. Zachary has always impressed me from the beginning. So we're very happy to be here today. You might notice the title of my talk is different than what I sent out. That's because there has, after my discussions with people yesterday, it got me thinking, and I kind of revised my talk to maybe better meet the questions on your minds, but we'll see. And the overall question I'm going to be considering is, what will it take for human-scale mobile manipulators to be happily used in homes? And really, it's a little bit more complex than that, but it doesn't fit as well in the title, which is, what will it take for human-scale mobile manipulators to be purchased and happily used in homes? And yes, I'm in industry, so obviously it's directly relevant, but it's actually more than that, because for it to be sustainable, it has to be the case that someone in society is willing to pay for those robots. And if that isn't the case, then it's not making sense. If it's some weird subsidized investment scheme, that's not real, right? They have to merit that value. They have to merit the purchase. So, okay. So what will it take for human-scale mobile manipulators to be purchased and happily used in homes? It's a mouthful, but I've got 4 main points I'm going to emphasize today. One is that the robot has to earn its place, which is quite challenging in the home environment. Second is that safety is absolutely paramount in homes. The next is I'm going to talk about an example design. And what I'm going to use is a robot that was invented in my lab at Georgia Tech and then commercialized by Hello Robot. I'm going to use Stretch as an example. I've thought a lot about that design. And then finally, I'm going to discuss what to me is a really promising near-term opportunity for robots to be actually used happily in homes and to earn their keep. And that's with people with mobility impairments. I think there's a real opportunity for them to be early adopters. So just a little bit about me. I've focused on in-home assistive mobile manipulation since 2006. I've been the lead inventor of a number of different robots that have tried to, address this problem. Most recently, the prototype that led to Stretch and was commercialized by Hello Robot, which I co-founded in 2017 with Dr. Aaron Netzinger. And Dr. Aaron Netzinger and I, we go way back. We were at MIT together in Rod Brooks's lab. So this isn't the first time I've been here. Back in October of 2008, I gave an RI seminar. And remarkably, it is still available online. It's an Adobe Flash FLV format, but I am amazed that it's still there. I really respect that, and I I gritted my teeth, got ready to cringe, and I watched it a couple of days ago. And, what's interesting to me is I actually bought into it. I was like, yeah, this makes sense. This is going to happen. This is real. And what I was doing was I was presenting what really is the ancestor of stretch, which is Ellie, statically stable, small footprint, cameras high so it can see the world kind of like people, can reach floors and countertops. And I presented work where we were really inspired by service animals. So this laser pointer interface that we developed was inspired by service monkeys. And people use a laser pointer to direct the monkey. And in this case, it basically is this clickable world. You would designate a location in the world with the laser pointer. There was a catadioptric camera that could see the whole room in the robot. It would recognize that, laser pointer has designated something. It would move its stereo pair to look at it. It would estimate the 3D location relative to the frame of reference of the robot. And then, based on the context, it would take actions. So for example, if you designate an object on the floor, it would go and pick it up. If it was holding an object and you designated a location on a surface, it would place it there. If you designated a person, then it would hand it out to them. We also later did things like if you designated a door handle, it would open it. Or if you designate a light switch, you would operate the light switch. Or drawer, you'd open the drawer. And it was a really powerful way of giving people access to the robot. I also presented in that talk work we did on haptic door opening. One of the reasons for that is because, if it's locked, it's not going to be visually obvious. You actually need to sort of apply forces to recognize that it's locked. And our approach, I still believe in it. I also presented early work where we were looking at what objects do people with ALS would they prioritize for robotic retrieval, and in particular, if it's a dropped object. So if you have ALS, it's a progressive neurodegenerative disease, you start losing dexterity, you're more likely to drop an object. And when we did studies with people, that object could be on the ground for 30 minutes, sometimes I think 2 hours, maybe was the longest. And interestingly, and this is the first time I saw this, and I'm going to touch on it at the end of the talk, we would talk with family members and they would be happy to pick it up for the person if they were to ask. But the individuals, the people with ALS, they wanted to do it for themselves. They did not want to have to ask their family members to do that. They wanted that sense of independence and autonomy. The other thing is grabbing it for themselves was a real risk because they could fall out of their wheelchair. So it was fascinating, and these are objects and examples of the performance of the robot later evaluated with those prioritized objects. I presented work where we were inspired by service dogs. And one of the things for service dogs is that people will modify the environment by attaching a towel to a handle or a door knob or door lever so that the dog can actually open it. And then we actually took a handbook on training service dogs and we were applying that to robots. So you could use a laser to designate one of these things, and then you could have a verbal command coupled with that. And then it would be sort of analogous to what the help that you would receive from a service animal. And then finally, I presented work that was our initial work with actual people with mobility impairments. This is Norma Margison, who is fantastic. She was so helpful for our lab. She was very supportive of our research. We learned so much from her. And the results were really promising. It seemed like not only was there this need, but there was an appreciation for the potential for this technology. It was also extremely humbling because it was 17 years ago, right? Why aren't people benefiting today? I'm buying into what this guy is saying. That guy happens to be me when I was a lot younger, but if I had asked him, I would have said, no way, it's not going to take 17 years. And of course, we're not there yet. So, that's a lot of what I'm going to talk about today. Is what will it take for us to actually get there? So, it makes me think of this quote by Richard Feynman, which I really appreciate, which said, for a successful technology, reality must take precedence over public relations, for nature cannot be fooled. And I think in AI and robotics in particular, as researchers, it's easy to underestimate the complexity of nature and the challenge ahead. And that's classically happened over and over again. And I certainly have fallen prey to that. So for this to happen, the robot has to earn its place. And that is no easy feat because homes are these personal spaces. They often contain what people value most. In particular, family members and guests of all ages and abilities, kids, your pets, sentimental objects. And the reality is that in this busy world, people have limited time, space, and patience to deal with some big technological artifact in their environment. It has to earn its place, not just because of the price, but because it occupies space. It's going to get in your way. It's going to mess with your stuff. Worst case, it could put people at risk. And like when I have my parents over, I have a guest over, I'm not going to put them through a multi-hour training session to safely work with the robot like you might be able to do in industry. It's a challenge. It's a real challenge. So I'm a big fan of simple models, so I'm going to present some simple models today to help us think about these things. This is a simple model of technology adoption, and this is based on the technology acceptance model, which is something I learned about from Wendy Rogers when we first started working with together on home robots back in 2010. And the notion is that perceived usefulness and perceived ease of use have predictive value in terms of estimating whether or not a new technology will actually be successfully adopted. And I'm going to use this simple model to give a note of optimism, which is that, I really do believe that eventually human-scale mobile manipulators are going to be in millions of homes. Eventually. So I'm also going to augment it with price, because the reality is it doesn't matter how useful it is and how easy it is to use. If it's millions of dollars or something, it's not going to happen in homes. And this is it. There's the simple model, which is just the notion that over time, semi-monotonically increasing, I think perceived usefulness and ease of use will increase over time. I think the price will go down over time. And eventually, you'll hit some point where these are so high and the price is so low that you can get this into 1 million homes. I do think that will happen. It's not going to be easy. I don't know when it's going to happen, but eventually I do think that will happen. I'm also optimistic because adoption of home robots at scale has happened before. Specifically, the Roomba, it's hard to imagine this, but in 2002 it was launched. It's an autonomous robot. It's 23 years ago, and it made it to millions of homes. And I know this well because I was in Rod Brooks's lab at the time when it was hitting 1 million homes, when they were going through, iRobot was going through its IPO. And I started it here at Georgia Tech, so you can see why I'd be awfully optimistic. I'm like, yeah, this is the start of something. Next step, we're going to have human-scale mobile manipulators. But it's not so easy. And I'm going to talk a little bit about why it's not so easy. We can kind of check our simple model, and we can look at this example with respect to it. Perceived usefulness, well, it autonomously cleans floors. It's a clear way, a clear task that you actually care about, and people understand. Perceived ease of use, well, one thing, it's just small. It's safe. It's easy to move. One of the beautiful design aspects of this robot is that if you don't like what it's doing or you need it somewhere else, you just pick it up and you move it. No problem, because it's super lightweight and small. And then finally, the price. It was $200 at launch. And then in today's dollars with inflation, I saw estimates about $350. And I've talked with Rod about this. He was my PhD advisor, and he was one of the co-founders of iRobot. And he's consistently emphasized the importance of a low price and how important that was to their thinking. They had done this Hasbro toy where it's just brutal, the toy industry. They're arguing about pennies. And I think that helped them achieve this amazing accomplishment that seems like it's so far ahead of its time. And one thing he's talked about is they wanted it to be the case that a person could be comfortable buying the robot without getting permission from a life partner. Which is really, not a bad idea. Okay, so that's one simple model: perceived usefulness, perceived ease of use, price. Safety merits additional consideration. It merits being pulled out and thought of kind of separately. And once again, I just want to emphasize, this is this very special personal space. where the things we care most about are located. And in particular, family members and guests of all ages, pets, and then, sentimental objects. I'm kind of sentimental, so I feel that one. And the reality is that human scale has safety implications, because human scale is great because it enables human compatible perception. The robot can perceive the world in a way that's similar to people. It can enable human compatible manipulation because a robot can manipulate things that people are manipulating. But it also tends to, just because of the physics, it tends to result in robots that are larger, stronger, and heavier, which means that they are more dangerous. And that is a real challenge. Oh, God, unbelievable. Okay, so let's play a game of Have You Ever? I want you to raise your hands on this. Have you ever had a device run out of batteries unexpected, a phone or a laptop?
At my job talk.
Oh, so painful. Okay, have you ever had a computer fail unexpectedly, such as that blue screen of death? Have you ever had a kid or pet do something unexpected around you? Have you ever been careful around an older adult due to concerns about them falling? And then finally, we're AGI, right? We're like full human bodies, I'm wow, respect. Have you ever stumbled in your own home? Okay, so, we're asking an awful lot of robots because it just takes one fall. And that notion is over, right? And I'm also going to talk about two minor tragedies that I have personal familiarity with, which I think hopefully will be a little bit sobering depending on your ambitions in home robotics. Okay, so my kids and I, we are responsible for dishes. That's one of our family jobs. That's one of our family chores. We have a lot of bar glasses like this, which I love. But I don't know, once a year, maybe more frequently, one of us, as great human AGI complete kind of thing, we drop it. And it smashes on the ground. And it is a minor tragedy because all of a sudden we're like posting signs, don't walk here with bare feet. We're finding little glass pieces a couple of days later, and eventually we get it all cleaned up. But we all love each other, we're family, we forgive each other, no problem. I at least for me personally, I don't think I would afford that graciousness towards a robot if it were to drop a glass like that. Another example in the same theme, which just happened to me last year. Okay, this mug looks kind of, old, and, who cares about that? You look on eBay, it wouldn't be that expensive. You get a whole new one, right? So if a robot did a lookup, it'd be like, no big deal if I break it. But, for me, this is a sentimental mug because I got this on my my honeymoon in Hawaii, about over 20 years ago. And through some weird chain of events, I had it on a counter over the last year. I opened a cabinet. An object fell out of the cabinet, hit it. It toppled on the ground and smashed to pieces. Now, yeah, I'm kind of responsible, but I also was thinking, like, who did that? Who put that thing unstably in that cabinet, right? And, maybe it was me. But it's a good thing there wasn't a robot to blame, because I'm sure I would have been like, it was that robot. That robot did it, right? And, I actually did end up going to eBay and getting a replacement, but it's not the same, right? And so one thing to keep in mind about this, these personal spaces, I don't want to go for a robot and tell about every little thing about why it's special and important, and please don't break this. This has personal value. And it's not something that it's going to be able to get from the internet or foundation model about what those things are, because they're personal and they're very specific. Okay, so, and just if it wasn't obvious, to me, this means that kind of general purpose dish help and dish assistance with washing dishes for home robots, I think it's really challenging. I think that's going to be quite hard to achieve. If you're tech bro and you're okay having just a bunch of uniform plates that are all plastic that it's been trained on, it's plausible, right? But I think for a family like mine, it's hard to imagine that happening anytime soon. Okay, so I've given this perspective and on why it's challenging. Now I'm going to give sort of a concrete example of attempting to address these challenges through the design of a robot, specifically Stretch. There's an ICRA paper on it. Like I said earlier, this was my lab. We invented in my lab, really with the notion of a robot that would provide assistance to people with mobility impairments. And then we commercialized it, in particular with this company I founded with Dr. Aaron Edsinger, Hello Robot. So the core design problem here, as you might have gathered, is that as you make a robot smaller, lighter weight, and lower cost in order to reduce the danger, in order to make the price lower, you also tend to reduce the reach, you lower the force it can apply, and you reduce the dexterity because you want to minimize actuator accounts and such. And so there's this fundamental tension about can you achieve these sorts of goals while maintaining the capabilities that still keeps it useful? So the approach we took with Stretch, and I'll say Henry Cleaver is a student I worked on this with. We invented it in my lab. Just want to make sure that acknowledgement's there. So one of the key notions here is it's a real minimalist attempt. So minimize the actuator count with the notion that actuators are one of the main sources of cost and complexity in the robot. And in particular, instead of the classic approach of where you take some standard serial chain arm and you attach it to a mobile base, in this case, the mobile base is required to achieve dexterity. So for example, in this Cartesian configuration, you have to move the differential drive base backwards and forwards for Y, the prismatic joint, which is a lift, up and down for Z, and then the telescoping arm in and out, X, for X. And then in the latest version, it's got 3 DOF wrists. So you do have 6 degrees of freedom, and you actually have redundancy, but it's got this weird differential constraint in the differential drive of the mobile base. So that's kind of the notion. And one thing that you probably notice based on this is that it's not a humanoid, right? It's very much not a humanoid. And so I want to be concrete about this. Humanoids look useful and easy to use, and clearly they're compatible in a certain way. But they also have a lot of practical considerations that I think are going to limit adoption in homes. More degrees of freedom tends to lead to higher cost and more failure points. Higher center of mass means more energy transferred when it falls. And then because it's not statically stable, there's a greater fall risk. And it's awkward when it's turned off. If you've ever tried to move someone who's unconscious or who's just not helping you, it's hard. It's quite awkward. I also want to note that biological inspiration can be misleading. It's a useful tool, but this to me is a historical example that's worth considering. My understanding is Edward Perkins Frost was a well-respected aeronautical engineer, but his approach to flight was very literal. Right? It's an ornithopter and it has very bird-like features. Where at the exact same time, the Wright glider was happening. And when we look back, we'll see. But there's a risk that if you're overly wedded to biological mimicry, that you could look like Edward Frost instead of the Wright brothers. And then finally, it is absolutely true that a home robot's body depends on the human body. For one, you want the robot to interact with you, especially if it's for physical assistance and activities of daily living. So that is dependent on the human body. And then homes are structured for the human body, and then you want the mobile manipulator to interact with homes. So it's dependent, but it's also the case that dependency does not imply a humanoid robot, right? That's just not how that works. Okay, so with Stretch, one way we think about it is this robotic cubism. In cubism, they kind of take apart the human body and then reconstruct it in interesting ways. And if you squint for this painting from Pablo Picasso, you can see a person. There's a person and elements of a person in there. And similarly with Stretch, the dimensions are matched to human environments, and it's kind of the human form deconstructed and reassembled. And I'll talk about that now. So for one thing, the width of the robot is less than 50th percentile hip width. And why that's important is because humans tend to structure their environment so that they can walk through them without having to go sideways, without rubbing against things. And so the narrow channels that we form in our living environments tend to be such that a robot with that kind of dimension can go through it. Another example is just the arm is about 50th percentile human arm length. And once again, in order to reach objects, if a person places an object there to make it so that the robot can reach there, that's makes sense in terms of matching anthropometric dimensions. It reaches the floor. The floor is an incredibly important workspace, especially for assistive use cases. I've had a number of robots I've worked with, the PR2 in particular. I love the PR2 mobile manipulator, but it could reach a space maybe like that big in terms of on the floor. So this is it's helpful in that way. And then it can reach 36-inch countertops, and it can reach the back of the countertop. And then importantly for assistive use cases, it can reach about 95th percentile eye height for wheelchair users. And then it is statically stable, and the design is such that it has a heavy mobile base. We attempt to minimize the mass above that in order to keep it more stable. And then I said I'm a fan of simple models, so here's another simple model. So I actually think gravitational potential energy as a measure is not a bad measure of ease of use. And why do I say that? Well, so first of all, just for a reminder, gravitational potential energy, units is joules. It's the mass of the robot times gravitational acceleration times the height of the center of mass. And it's indicative of a few things. So first of all, fall risk. MGH models the energy that would be transferred if the robot falls. Second, it's proportional to the difficulty that you're going to have, or at least related to the proportional to the mass of the robot, which is related to how difficult it'll be to move. And then finally, and this is a little bit more complicated, but I've got another slide on it. H, the height of the center of mass, is proportional to W, which is the width of the robot's base required for static stability on a sloped surface. So, and this you can see that here, which just H is proportional to the minimum width of the robot's base of support for static stability on a slope with angle B. And to me, one of the nice things about this is that then you can create a landscape for the design space. And so the y-axis is representative of ease of use, MGH, joules, that's the gravitational potential energy. Then you have the affordability. And to the extent that the robots you plot on here have comparable usefulness, then it gives you some sense of like where you want to be. And I would claim that where you'd like to be is kind of as far up and to the right as possible. And what I think in general, like this is an example, this 100 joule line I think is significant. That's like 30 kilograms and about 1/3 of a meter off the ground in terms of the center of mass. If it had a base width of about 0.4 meters, which is maybe a little more than 50th percentile hip width, then it'd be stable to like 30 degrees. And if first of all, big approximation here. Caveat, I couldn't find the actual documented center of mass for some of these, so these are approximations, but I think it's in the ballpark. It's in the ballpark of where things are. And stretch occupies a pretty special place. I mean, it's pretty far up there and away from other alternative robot platforms. This also means that it's easy to move around. You can tip it over and roll it around. Easy to transport. You can put 3 in a car. That's Blaine Matulovich, employee number 1 there. Of course, and all of that is sort of irrelevant if Stretch isn't capable. So, what was our approach to making sure that Stretch is capable? When we started out, we kind of had 2 things. One is we did teleoperated examples. I was doing development in my home, and so I was able to do various tasks by teleoperating it. I was using a gamepad. I played with my dog, which was a lot of fun. This was especially fun. I played with my kids. I was, it's a dangerous role the robot's playing. I was glad I wasn't over there because that chicken just got destroyed by these Nerf bullets. And we had a lot of fun. I was able to pull laundry out and things like that. We also, autonomy in teleoperation, just because you're good at teleoperation doesn't mean you're going to be good at autonomy and vice versa. So also did autonomous examples for grasping and such. a natural question is, what about bimanual manipulation? Now, this is real feasibility kind of work. So everything I'm going to show you is teleoperated. As far as I know, no one in the community yet has automated it. But the notion is like, look, why don't we can simplify adoption? If people get one robot, one arm, and it's working well, then if they want to get another, great. And then it's easier to move them around because you've kind of factored it into these two platforms. And then interestingly, it has these, it increases versatility because you can have this object between them, and you've got kind of like, it's almost like having variable width shoulders. And I think it's especially could be interesting, and I'd love for someone to look at this in terms of assistance, because you could have them on each side of a wheelchair or each side of a bed, I guess. And I actually suspect that's maybe more advantageous than a humanoid form for providing assistance. But so this is work I did. I just created a simple teleoperation system. This is in my home. I'm teleoperating it just to kind of demonstrate the feasibility. But it is, it's sped up, it's teleoperated. In this case, I'm not using Cartesian mode. The base is restricted to rotation. This gives you a sense of kind of the maximum payload.
That looks like dog snacks.
You are correct. This is one of my favorite moments because we hadn't done this before. It's the first time. And she's like, oh, wait, can we play? Oh. I think there's this moment where she recognizes that. And of course, got to do folding. And I did this many times. It was sort of like speed running a game. I was getting better and better, but eventually I had to call it, and this was the best I had. So hopefully that's enough to convince you that the balancing act between capabilities and reducing the complexity, reducing the risk, reducing the price is reasonable compromise. Actually, hopefully it doesn't, now that I think about it, because what we really want in the end is we want this to be in the real world, right? So we actually have to take it to another level. Is it useful enough? Is it easy enough to use, safe enough for the robot to actually earn its place in homes? Well, so far it hasn't earned its place in homes, but it's definitely earned its place in an amazing community of people who are doing research, development, education. And it's really all over the world, 22 countries, and I am so happy about this, and I love the community. And then I will note Beneet Shah here, employee number 2. He plays a major role in helping this community thrive. And you may have even seen him on campus. So in that sense, it's earning its keep. But of course, we'd like to get in real homes. And that was the original inspiration for the robot. So what I'm really optimistic about at this point, and I think we're on the cusp of, is for people with mobility impairments to be early adopters of this technology and to actually happily use it and hopefully pay for it, or at least someone will pay for it. So some of the reasons I believe that, one is that the high-value tasks in this application domain are technically achievable. Second is that for this application domain, supervision and direct control can actually have advantages. So if you're in self-driving, you're like, oh no, I've got the additional cost of some remote operator. Am I going to make this work? But in this case, the person with mobility impairments can, in many cases, derive benefit from having control of the robot and supervising the robot, because it enables them to be more independent and to have more autonomy. And then finally, one thing we see is that robots actually have benefits over human assistants. Like people who could have a human assistant or do have a human assistant, whether it's informal, such as a family member, or a paid assistant, they want to do it for themselves. So I think those bode well for this actually getting out there. And this also is being pushed forward by the community. That's one of the reasons I actually have confidence, including Professor Zachary Erickson has done, your own, I should say, homegrown hero. Hero, dare I say? No. Anyway, Best Paper Award at HRI 2024. Really cool approach using this head-worn interface to give Henry Evans, who's this amazing pioneer with severe mobility impairments. He's a pioneer in that, testing out robots and working with it. And Henry was able to use this intuitive system for 7 days in his home to do a variety of tasks for himself. Another example of how this open community where, just to be clear, the robot that's sold, all the software on it is open source from the firmware up. And so that's one of the things that enables the community to really explore what's possible and to build and share. And so another example is at the University of Washington. I had created, prior to launch, this pretty crufty, not very good web teleop system inspired by work in my lab, which was much more refined from Dr. Phil Grice. And then we put it out as open source. And then Professor Maya Chakmak at UW, they took that up. They started improving it. They were testing it with people successfully. And then Dr. Vinitha Ranganeni, who is now actually at Hello Robot, she did her dissertation on this technology and made it even better in collaboration with others. And at this point, this accessible web interface is actually pre-installed and tested on stretch robots. And so here's an example of kind of what that can do. I think that's Vinitha, Dr. Ranganeni there, controlling the robot from across the country to do some tasks here to give you an idea of what's possible. So it has, one thing is that for this approach, you kind of sprinkle in autonomy to make it more useful and usable. Like in that case, map and autonomous navigation. And more recently, there is this kind of autonomy for pre-grasping. So you click on an object and it will position the gripper in preparation for grasping an object. What's especially exciting is that web interface has now been used by Henry in his home in collaboration with Henry and Jane Evans, whom I spoke about before, and in collaboration with a number of people in the community, including Professor Wendy Rogers and Professor Maya Chakmak, Dr. Fi Wen, and Dr. Oh, gosh. There should be a doctor there. This was before she had earned her PhD. And so what I'm going to do, I'm actually getting close to the end. There are two videos I'm going to show you. This first one, so Henry's non-speaking, so he's going to communicate with you through this video because I can try to tell you, but I'd like you to hear it from his perspective.
Hello, my name is Henry Evans, a mute quadriplegic since 2002. Recently, I have spent 3 summers exploring different ways to use the robot stretch. To really appreciate what stretch is for me, first have someone bind you to your bed so the only thing you can move is your head, and let you lie there for a couple of days. Have them do this when you have a lot to do. Then imagine what it is like to be in this condition for 30 to 40 years. Yeah, it's no picnic. Now imagine that, instead, after 10 years, someone brings you a robot that you can control in a web browser on your computer to scratch your head when and where it itches, feed yourself when you are hungry, and in general travel through and manipulate your environment. Children are really drawn to robots, and Stretch is a good example of that. My granddaughter used to ignore me because I have paralyzed and mute. When we mounted a tablet with my image on Stretch and told her I was controlling Stretch and wanted to play games with her, she started playing with Stretch and talking directly to me.
I got 8 jump picks.
From getting Jane a rugs, to feeding myself small, soft bites of food that I fetch from the kitchen using Stretch, to playing my own hand in card games. Our work with Stretch should give you some idea of how robots have improved my life.
So, I think one thing that has had a real impact on me is just over time, it's very much changed my perspective on what is valuable and meaningful and useful for robots in homes, right? And, with Henry, I just want to give a few addendums. So scratching an itch was like this was back in 2010, it was the first thing he wanted to do with the robot. It's like, why, Henry, why is this so important to you? And he's like, many times a day, I think maybe he said 50 times a day, he gets an itch and he couldn't scratch it, right? Can you imagine that, right? That's significant. That's, this is something that's cool about this is that, he developed this himself, right? He came up with this notion of how he wanted to eat and he worked with people to develop it. And I love that Henry is this pioneer in the community, who is finding ways to help himself and others. And he and Jane want to do this work, not just to help themselves, but to help others. One thing that's cool about this, when I had my lab, we did a lot of work with Henry, but almost everything was around activities of daily living, which is like things like hygiene, right? Hygiene and dressing, and feeding assistance. I hadn't really considered the possibility that this kind of robot might help reinforce social connections. And that's something that's been really well explored now by work with Hello Robot and Dr. Vi Wen. She is now has a PhD, or she's a doctor of occupational therapy. She's an OT, and like this, she designed, I believe, this device so that Henry could play cards using the robot, and it was really powerful for him to be able to connect with his friends in the way he wanted, and not have someone else messing with his cards, right? Because he's kind of competitive. This just blew my mind. I really had never thought of this. I mean, I did various things with Stretch in my home with my kids. One of my favorites was hide and seek because it leveled the playing field, right? Usually you may or may not know, like if you're playing hide and seek with a 5-year-old, a lot of times you're like, you see them, but you're telling them you're not seeing them. But when I was teleoperating the robot remotely from another room, I really had to work at it to go and find them. And so that made it a lot of fun. We had a great time. But this is something totally different. Henry just hadn't connected with his granddaughter in the way he had wanted to. And yet through this robot, it somehow changed the nature of their relationship. And this is something he keeps coming to me. He's like, you got to go talk with a developmental psychologist or something because this is something very real. And of course, it encouraged the community to look into that. And then finally, this is another example. He just briefly mentioned it. And this was the first time where it really hit me. This was it was during the pandemic. Vi Wen, occupational therapist, this was part of her dissertation work. She was deployed in their home. It's in the middle of a pandemic, so it was just the three of them. And Henry really wanted to do something special for Jane. And they had this idea that he would, get this rose and surprise her with it. And it was this super touching moment. The physical assistance and his ability to control it in that way, even though it's through this robot, Jane recognized that it was Henry doing this. And it was this meaningful moment that reinforced their social connection. So, for me, in spite of all these years, 17 years, I keep getting surprised at the ways that this type of technology could enhance life for people. I want to end with this video.
Most part, I don't have any functional usage of anything below my shoulders. Giving up all your withdrawal is basically what happens when you get a spinal cord injury and we're trying to work towards getting some of that control back. When that sense of empowerment and autonomy. First thing I would say out of the chute was, I saw what could be done with voice control and various things. We have phones now, so I will say I'm fortunate that I have a lot of home automation in my house. I can execute my free will a lot easier, and I hope that, and me personally, I hope that that's what Hello Robot can extend. So yesterday I was eating delicious apples with this program that they developed for me, and it was awesome to could eat at my own pace. I didn't have to ask for any help. It was empowering. And so I hope it creates more things like that. And secondary to that, I think if this progresses, could help others that maybe don't need the same level of care of me, but they need some care. And we help them have more independence.
So that was a person we just started working with in November. Bob is he is another pioneer who really sees the value of the technology, wants to help develop it and have others benefit from it. And one of the significant milestones that we've been pushing on and working on with Bob is to actually achieve daily use without supervision. Because our work with Henry today, the work in my lab, there's always a researcher there. There's always someone there just in case. And so that's been this hugely important effort for us and a hugely important collaboration for us, because we're really taking seriously the notion of getting this into homes and providing an assistive version of the product. And working with Bob, I think it's making a big difference in getting us there. And one example of that is one of the things he wanted to do is he wanted to go get a shake off the counter that he has daily, bring it to himself and hold it out so he can drink it at his own pace and not worry about someone holding it, because people get tired, right? And he has used that on a daily basis while he was having a shake, and it was great. And then the feeding, I'll just note, it is using some of the nice new AI. It's using fast SAM, so fast segment anything, to create virtual buttons on the food, that enabled him to select which piece of food he acquired. So with that, just to summarize, what will it take for human scale mobile manipulators to be purchased and happily used in homes? Well, the robot has to earn its place. That's not going to be easy. Safety is absolutely paramount because of the important things in our homes. I presented example design, Stretch Robot, which is sold by Hello Robot. And then my belief that people with mobility impairments are promising early adopters. And I truly am, in spite of those 17 years, optimistic that it's in the near future. This is possible, we can get there. And what I hope, there are already people working with it, the platform. The community is amazing. And this community does so much to help get the technology out there and to help us progress with it. And I invite all of you to be a part of it, because that's really what's making this happen, is the community and the collaboration between great people like you and Hello Robot and people like Henry and Jane and Bob, who are pioneers. So thank you. That's it.
Imagine we have time for questions, if anyone has.
Thank you, Charlie, for a super inspiring talk. Learn a lot. So you have a lot of analysis for morphology. I wonder, how do you think about Dex hand? Do you have similar equation as MPG for?
You mean for a dexterous hand?
Yeah, beyond gripper.
I think it's a really
fundamentally, do you think we need that for making mobile robot in the home?
So that's a great question. I didn't point it out, but it is actually the case that it's at least mechanically easy to remove the gripper and put a different one on. And we're working to make it so that it's also electrically easier, because we recognize that I think it's an open question. The nice thing about this is the platform can do a pretty good job of moving an end effector around. What that end effector should be, I agree that I think that's an open question. I do think for initial applications in assistance, a fairly simple gripper will probably be sufficient to help people. But in the long run, I do think there are a lot of opportunities there, and it's a really good question. Yeah.
And just curious, like, how do you compare Stretch with another solution, like you're putting 2 arms on the wheelchair for people like Henry and Bob?
Yeah, and I didn't go. It's a great question. I didn't go into that in detail, and it's definitely a longer discussion. But there are a few benefits of a mobile manipulator. One is, first of all, Henry spends most of his time in bed.
Right.
And so, bed is a big workspace. It's advantageous for the robot to be mobile, and he wants to be able to task it and go have it do things for him. And there are a lot of people with mobility impairments who are in bed a lot of the time, or who are seated down in a non-mobile way a lot of the time. So I also say, because of the nature of the technology, I'm optimistic about just economies of scale because it's more generally useful.
Makes sense.
So those are I think there are other benefits, but those are the ones I'd go. Well, I guess the one other thing I'd say is that, with 2 challenges with robot arms and wheelchairs that I've heard come up that are off the top of my head. One is, it makes your wheelchair bigger, it's more encumbering. It sort of implies you're going to have a powered wheelchair. There's this installation challenge of like connecting it to the batteries and everything. At least with Canova, someone usually, at least in the past when I've talked with people, someone has to come out and install it. And then it's also, one of the things people like about the mobile platform is it can go places their wheelchair can't, because it's smaller. So I think that's definitely a significant consideration. Maybe that's it. Maybe I hit the 2.
Sorry, this is the last question. Very
Okay.
Yeah. How do you improve like Stretch for more heavy duty tasks, like lifting like 10 kilo box, or like a heavy door? Just like if you can design.
Yeah, that's also a great question, and I think. And Chris Atkinson used to talk about this. There's sort of these 2 regimes, right? There's a regime of fairly small, lightweight objects, and then there's this regime of very heavy objects, like lifting a person. And it's so different. I think the designs required are quite different, and so I'm not convinced that you want to try to hit both of those. Certainly to start out with.
Agree.
Yeah.
Thank you so much.
Hey. This was a really wonderful talk. Thank you so much. And I really like your kind of 3 axes that relate to adoption of price, ease of use, and capabilities. When you think about like where Stretch is right now on that kind of space, what is the direction of your kind of optimization gradient going forward? And I think Guanya stole a little bit my question here, but like as you continue to push Stretch, are you looking to, like already seems to be ease of use is great, are you looking to drive the price down, improve capabilities, some combination thereof? What's next in that kind of space?
Yeah, I mean, that's a great question. So one thing you probably noticed, we are on a 3rd version, and we are very explicit about having an iterative approach. Now, I honestly have no idea when the next version is coming out. I just don't know. I know we are obviously working on a new version, and we definitely listen to feedback from the community, including our pioneers with mobility impairments. In terms of, I at one point thought we would do price, but I think what we've come to realize is that first we really need to make it useful, right? Otherwise, we're just going to end up with another throwaway toy in the graveyard of robotics companies. We want it to be something that gives real daily value to people, where they care about it. And that's what I'm passionate about in terms of the mobility impairment space. And I think the best thing to say would just be, we try to follow the gradient provided by the community in this iterative approach. And what we're going to be doing is weighting, as in our objective function with the terms, we're going to be weighting more the feedback we're getting from people with mobility impairments using it in homes. And I think what's nice about that is that everybody benefits, right? Because if we can make it there, we can make it anywhere, any sort of human environment. And I think it will be beneficial to researchers and educators. I'll also note, I have this vision, I mentioned that, where I'd love to have it like there's a wormhole between R&D and education and homes with people, where it can kind of, it's quick. If you create something, it can go there. Now, the nature of that wormhole might just be an app store, much easier in terms of the physics. But that's another thing I hope for. Does that kind of get to it?
If I can ask a super quick follow-up too. Thank you. When you look at increasing that capability, do you have an estimate of how much of that is hardware versus algorithms in terms of how to really drive the capabilities? Because some people are totally on the end of like, oh, we can with really cheap hardware really focus on algorithms and get really great performance, whereas other people say we need to really drive our hardware forward.
Well, first of all, I'm computer science major from MIT, so I love algorithms, and one of my happiest things to do is be coding with the robot by my side. But I have to be realistic. Algorithms aren't the major issue. It's something about the system and usability and ease of use, and it is a combination of interfaces and hardware and even communication and documentation, and it's a very subtle thing, and algorithms are a part of that. I will say this, something I'd love to see in the research community is, I have these feasibility demonstrations I did in my home of bimanual teleoperation, but there's this challenge, I think, that people, well, first of all, I'm not sure where people are, but my impression is that not a lot of people have really taken up that challenge to try to automate that. And I think part of that is because the mobile base is serving as this rotary joint, but unlike a robot that's fixed onto a table where you have very precise and consistent, high precision accuracy feedback in terms of the joint angle, there's going to be some slipping and stuff on the ground. That's a place where I'd love to see algorithms developed to, can you get the wonderful things that are happening for arms with fixed bases, or whether that's a mobile base that then plants itself, but to see how well you could get that on these robots where they're, the interface for that joint is with the ground. Does that make sense?
Yeah, that's great. Thank you so much.
Okay. Yeah.
I really enjoyed your summer talk. I have a more human-centered question.
Love human-centered questions.
And it's like, so we're very creatures of habit, right? And so I was wondering your opinion on how much these robots should work with existing human habits and how much they should be, like, we should encourage others to build new habits centered specifically around using these robots. Because, like, for example, dishwashing one, you probably have a specific place you want to put the dishes. You have dishes that you want to be thrown into the dishwasher, but other dishes you want to be hand washed because they're either like fragile or whatnot. And so, like, this is like one of those habits where you might want to tell the robot the distinction between the two. But in other situations, like the Roomba, for example, it just gets rid of the vacuuming habit as a whole. So, like, where does that balance happen?
Well, first, I do think it's a great question. And I don't have an answer for it other than a methodology, which is, human-centric methodology, which is that you have to work with people to understand what they want and what would actually, if you're going to have them give something up, you've got to give something in return. Is the thing that you're proposing to do with the robot that requires them to change their habits worth it? And I think that's very specific to individuals and their needs and what you're trying to do with the robot. And I don't know of a way to do that other than to get out of the lab, get in there, in homes, talking with people, working with people, and seeing what's possible.
So 70 years ago, you gave a talk at RI. And a lot.
17. I tell you what, I'm going to go into the anti-aging world in 70 years for sure. Okay.
So you showed a lot of slides on 2008, 2007 IROS paper, ICRA paper. Pretty similar to the stretch robot you're building right now. But I want to ask, let's say, after 70 years from now, will we have another RI seminar with you? And you telling us, well, after another 70 years, very few things changed. Is that possible? Or what's your take on that?
Okay, first thing, reality check. You said 17, another 17 years?
Yeah, 17.
So I'd be 69 years old. I think I'm going to refuse an invitation at that point. My guess is I'm retired and I'm doing other things. I have a man of many interests. I am hopeful, but the reality is there is only one way to find out. And that's to just work like crazy to make it happen. It's one of the reasons I gave up tenure. It's one of the reasons I founded the company, because I'm not going to give up, and I'm going to work to make it possible. But you don't know until you're there. I think we're close, but until it's actually there. And I think that's the way it is with these things, right? It's such a complex thing. If I make a proclamation, it's kind of vacuous.
Yeah, because the feeling I got instantly is that 17 years ago, the work you published, people nowadays are publishing same papers.
Oh gosh, no. But there has been huge progress.
Yeah.
Huge progress. There really is.
But it's really pick and place.
It takes time. Look, robotics. It's 70 years of work.
Yeah.
And it's often the way these things. It's kind of this spiral. I think and I like simple models. It's this spiral. People keep revisiting ideas. And the state of the world has changed, and things that didn't work before all of a sudden, are starting to work. I mean, I took a neural networks class with Michael Jordan in the 90s, right? Pretty much the same, but then with computation and data, all of a sudden magic happens. And so you keep doing that spiral, and things keep getting better.
Yeah.
But the other thing I just want to say is, like, the future doesn't just happen, right? If there's something you want to see, if you're not creating the future, someone else is going to do it for you, and it might not be the future you want. You have to make an effort to create the world you want, and that's what I'm doing. Is that?
Yeah. But 17 years ago, if we have
You've already gotten me to reveal my age. What more do you want?
Yeah, I'm just trying to from 17 years ago, if we want a bot to chat with us like GPT, it's very hard. And now for NLP and CD, progress have made very rapidly. But 17 years ago, the work you did with Iris 2008, pick and place, is still so hard today.
It's definitely, one thing in terms of simple model again. The price, there is no doubt that the price has gone down dramatically. And I even thought of calculating what the price was and doing the inflation conversion for Ellie. But we were approached by businesses at the time because it got a lot of attention. It was way ahead of things. It was in the New York Times and Popular Mechanics. It was, it got a lot of attention, right? And so business people came to us, and one of the challenges was that the price of that robot, it was expensive, right? So that there is no doubt that to do these kinds of things, we were running on a Mac Mini, and then we were running on multiple Mac Minis, and especially when we moved to ROS, but that's another story. And the price has gone down. Sensors are, we had, here's an example. We had Hakuyo planar LiDAR, and it was $4,000, and that's not converting for inflation, right? Now you can get a 3D hemispherical LiDAR for $1,000. Tariffs aside, I don't know what's going on there. But so, and the computation is like completely different that's available. And then perception, which was always this great challenge in robotics, all of a sudden you can actually sort of trust it for some things, right? So, the world is better and has changed. Oh, and the internet, I was, as you probably surmised, I was alive when the great boom and bust happened, and, which sometimes I think with AI we're in a similar period. But it's now the fact that internet's so easy and it's reliable changes the game. So it's just that spiral, and it's really hard to predict, and sometimes it feels like it's going so slowly, and I certainly am impatient, but there's no doubt that we're in a better position now and that a lot has changed for the better. But at the same time, future depends on action, so if you have a vision, I highly encourage you to work on it. And I'll just also note, because I got this question a couple times yesterday, academia is extraordinarily important. And part of the reason for that is because you have the opportunity and the obligation for looking for the truth and communicating it broadly and educating people. And that is such an important role in society. It's so important. And even if it turned out that someone was doing something similar, inside some closed structure, it's not going to have the same impact. So please take advantage of that freedom and help us all.
Thank you so much.
Hi, thank you for a great talk. I had a question on like your vision of when you started with this robot that can be, in people's homes. Like you just said, in academia, we're looking for the truth and stuff, but we're also looking at very small, very like particular problems so that we can replace, parts or adapt to people's homes. So when you first started this company, with your vision of having it be in people's homes, did you envision it to be like one robot kind of working side by side with one person, or did you imagine it to be a whole fleet of robots kind of, doing various tasks around the house, and then do the pioneers who you are working with have their own vision of how they want kind of Stretch to be in their homes?
Yeah, and that's a great question, and I've given talks that sort of kind of address the, what's the chain of events that led to all of this. There was a lot, my lab, we did a lot of work, in that, some of that 17 years, right? And an example was we did a study, we created, Dr. Phil Grice did his PhD, he created this great web-based interface, and people with severe mobility impairments from all across the country controlled the robot to do this modified clinically diagnostic test, and what it showed is that there was a really good chance that it would make what's called a minimal clinically important difference or significant difference to them based on that. And that certainly was very impactful for me in my thinking. And at that time, the main issue was we were working with this robot. Is the PR2 is $400,000. It's like 3 feet wide. It was 500 pounds. And it's like, there's no way. Like, okay, it looks like this web-based approach could actually work, but the robot, it's not feasible. It'll never happen. And that was actually the main impetus for inventing the robot with Henry Cleaver, and then co-founding the company with Dr. Aaron Edsinger. And so, that's an example of where, the research inspired me. That partly, feel free to follow up if I didn't quite hit the mark.
I also have like what the pioneers almost think of, because a lot of my research focuses on what the people want, and so I guess like working directly with people who have the potential of using this in their home,
right.
What they imagine almost the robot to be like in their homes.
Yeah, I mean, and that, my lab from the very beginning, so what first got me into this was I was working on a humanoid robot in AI lab at MIT under Rod Brooks, and it was called Domo. It had 2 arms, and Dr. Aaron Edsinger and I did this cool work that got a best paper award at Humanoids, where you could like hand it objects and it'd put them up for you, and it seemed like it was very clever. There are a lot of cool ideas in there. I think it's so far away I don't feel like I have to be too modest, because that guy seems like very different at this point. And it was very capable, and I thought, oh wow, this could be useful to people. And in fact, I looked it up and I almost had a slide. One of the things that frustrated me is at the time it's very common to say, oh, justifying your work by saying, oh, and this is going to help older adults and people with disabilities, but not taking it seriously, right? And I looked back and I was like, oh my gosh, that's exactly what we did in the abstract. Like the abstract, even though we only like did some tests with ourselves or something, it says like, oh, this could help older adults live at home longer. So when I went to Georgia Tech, my primary appointment was actually biomedical engineering, which is a very human-centric approach, and then I had a joint appointment at interactive computing. And so I took it seriously, the notion of, would this actually benefit people? And from the beginning, we were working with people with ALS. Later, we're working with Henry and others. We've got projects with people with Parkinson's, lots of projects with people with older adults. And we worked with hundreds of people and got their feedback. And I think the thing that was shocking to me is just how it was also positive, right? And interestingly, it was more positive often after people actually worked with the technology and tried it out than before. Because I think when they would just see it, they think, oh, it looks a little intimidating. And then they'd use it and like, oh, actually, this is nice. In that study I was referring to where we had people from across the country doing this clinical test, we also did assessments, Dr. Phil Grice did, about the perceived usefulness of the system and the perceived ease of use, and using a Likert scale, and like the results were like very positive. So hopefully that gives more, and happy for you to look at the papers and cite them. Yes, I still have that bug. I still want people to read and cite my papers after all these years.
I was going to make this a two-part, but I'll only do one so that the other person is
This is the world of multi-part questions. I've noticed. I like it. I like it.
So my first question was more looking at people who need aids around the house, or different mobility aids. So I have a family member who suffered from a stroke, and while they do they wish to be able to do more things by themselves, there's also an aspect of human interaction because they can't go out of the house as much. So they do like to have someone who's coming in, because then they're having that human interaction. Seeing an increase of robots in the house, or robots doing tasks in the house, do you think we'll run into an issue where people are isolating themselves, where there isn't as much socialization going on?
I mean, I think that's a great question, and something to really we should be paying attention to. We're not at a point yet where that's a risk, but it could become a risk at some point. I think especially the risk might be in terms, an example of risk might be systemic. You can get reimbursed for using this technology, but then you're not allowed to pay for a human assistant or something, and so definitely need to be mindful of it. And I'll note that all this it's really technology. Where the technology is, reality is it's going to be this partnership for quite a while, and not just it's really at least a triad. It's going to be the robot, care partners, and the person who is, has mobility impairments. So, but it might just change how much time is and what the tasks are that people are doing. The other thing I do want to point out is, and one of the reasons I really try to emphasize these other social connection aspects, is that the technology in these cases, right, it increased social connectivity because it enabled the person to interact with family members and friends in new ways that they had difficulty doing before. And so I think it's a really good question, and we'll see. But I'm optimistic, at least at this point.
So I noticed the early design that has a lot of rotary joints, and then I think the current design is the telescoping. Why the change, and then what's the advantage there?
Yeah, I mean it's a great question. One of the goals was to reduce the number of joints, and you need a long reach for these things, to help to get to the back of a countertop, to reach to a person who's in a wheelchair or in a bed. It's actually a long reach. If you try to do that with a serial chain, you're going to end up with multiple joints. And then there's also this challenge of the swept volume. That's when you're actually reaching out there. Now, if you have those rotary joints, you're sweeping out a larger volume, and it's harder to maneuver where you want around a person. So those are some of the I think the reasons behind that design and motivations behind that design. Where things end up in the long term, I'm not sure, but that's kind of, does that kind of make sense? I'll also, there's an advantage in terms of interpretation that we've found, is that when the robot is, it's relatively easy for people to grasp how the robot can move, and so when the robot's reaching out, it's like, oh, I understand. Whereas sometimes with serial chain, it's kind of unintuitive how it's going to move. So that's a potential other benefit. But it's a great question.
Okay. Yeah. Thank you for a great talk. Very humbling. So you mentioned that computer vision and things are starting to be a little bit more reliable. So what do you think this era of robotics boom is different? And then what do you think has changed that makes you a little bit more hopeful?
The cycle of the spiral, I think, is quite promising right now. I should be clear, my expectations are quite different than some of the notions being put forward by other companies. I mentioned with dishes, I think right now I'm not comfortable with what some people appear to be selling in terms of the future of robots. But I think there are very much real ways that robots are technically capable of doing now that can provide real benefit to people. And I'm super motivated by that. And it does matter that the price is down. It matters that internet connectivity is really good now. Software, I mean, the other thing, software infrastructure is so much better. I mean, one nice thing is like, I mean, the spirals, it goes forever down there, but the spirals, I was around a long time ago, and it's a big difference. It does add up. That's right, we didn't have ROS. Oh my, and you're building everything from scratch, and you weren't writing. I mean, now we write in Python, and back then, maybe you're doing assembly or embedded Lisp, or often usually C or C++, and it's just things are a lot better. Oh, and even just sharing the infrastructure, like having GitHub, makes a huge difference. It's like it's I go and I get things, and I'm able to run the model, and they're open. That's a cultural shift. So. There are so many things that are different. I struggle to communicate them all, and but like I said, the proof is in the pudding. It's not happening until it's happened. And does that help?
So not all the AI stuff, not the autonomous AI.
AI absolutely plays a role, but consistent, predictable operation that's safe and reliable is very important in these application areas. And achieving that is really hard. And this is an unstructured environment. I think the nearer term opportunities are where there is a human in the loop, and maybe they're remote, maybe they're local, but they can provide supervision. And when you combine people with this the new technology, I think amazing things are possible. And I didn't talk about it, but I've seen like really things I never imagined. Like I taught a course, and students made this horticultural therapist and had ChatGPT, and it would talk about the plants with people, and then it would go and get time-lapse image videos of the plants, and they went to a senior living facility and worked with a horticultural therapist, and it was like really promising. Or students who did a project for people with mild cognitive impairment, and the robot could go around, find the objects, and then if the person asks the robot, hey, where is this thing? It could say, is this what you're looking for? And help them find lost objects. And then there's another project I didn't talk about where it's exercise with Parkinson's. And this came out of students. They took the robot out to a physical therapy center. They worked with people there and found, oh, look, the robot can do this exercise game with contact. And because of the way it works, it gives like this huge workspace. So people would now this is collaboration with Professor Madeline Hackney at Emory School of Medicine. And I think 11 people with Parkinson's have tested it, and 20 older adults, and they really like it. And it does this customized exercise fun game. There's all this people. I think right now we're in this strange point where people are focused on the human example and mimicry. Language. It's got English language, and you start imagining there's so much there that this is AI like humans have, or it's a humanoid robot, and you start imagining it doing all these things that people do. But to me, the real opportunity is robots are different. Robots are not service animals. They're not people. It's this protean technology that can do so much if we're creative and we look at it in different ways. But they're never going to be people. They're different. And that can be good. It can be complementary. A robot can just hold out an object all day long, as long as it's better, and it doesn't care. I can maybe get, I tried once, maybe 5 minutes, I don't know. So probably less. So I think what I'd love to see is people thinking more broadly about this technology and the roles and the unexpected roles it can play in society, the new things it can do that we've never thought of before, because there's a lot of low-hanging fruit, as opposed to things that are just, I think it's going to be a long time. Does that make sense?